So my name is Keith Alsheimer, and I'm the CMO for Unravel Data. So you may not know Unravel Data, but we are a DataOps observability platform. So what's DataOps observability? We are a platform designed specifically for data teams to manage modern data stacks. So what we do is in a single platform, we enable data teams to manage the performance of the data stack, the cost, and the data quality. So today, we're here to talk about one aspect of that, which is really cost, and specifically cloud cost. So let me ask a question of you first, just to see sort of where you are in your cloud journeys. How many of you have already started to migrate your on-premises data stacks over to cloud environments like Databricks or Snowflake or Amazon EMR? Who's already started that? So most of you, that's great. Anyone who's migrated most of their data stack to? Wow, where are you from?
Williams.
Oh, nice. And you too?
Yes.
And where are you from? Oh, wow, awesome. Big journey.
Yes.
How many are just getting started? Right, so you've got a lot of challenges you're figuring out, so you guys should talk later. Well, next slide, please. So what I'm sure all of you are discovering as you make your journey to the cloud is that, you know what, it's expensive, right? And mostly because just the size and magnitude of the data jobs that are running, moving petabytes of data. Most of you probably have thousands of applications running every day. And so for most of the customers that we have, the data portion of the cloud bill is the most significant portion, right? See head nodding, that's true for many of you. We all also know how strategically important using data is and getting that data into the cloud to be more agile. So we're in this race to be able to do it as fast as we can to provide strategic value to our businesses, but then we're also struggling with how to manage the cost of that. So a recent survey showed that over a third of businesses have cloud budget overruns by 40% or more. So anybody relate to that? So you're not alone. Most companies are facing that, and it's for good reason. And we're going to talk about what a lot of those reasons are as to why understanding costs in the cloud for data applications is very, very challenging, and not to mention even managing it. So what you might feel like is you're in a little bit of the Wild West. You've got everyone in your company trying to make use of data, trying to rush to get the value out of data, and then as managers of data teams and data platforms, we're kind of left trying to figure out how to control all of that, how to bring law and order and governance and make sense out of all of that activity of people using the data in the cloud. It's very distributed, it's very hard to have control, it's very elastic, so anything can happen, so a little bit like the Wild West. And one of the things that makes it particularly difficult and kind of like the Wild West is that there's no single way to govern and manage cloud costs. It really is a team sport that spans across all the roles in the data team, whether that's FinOps trying to understand it and govern it, or it's data engineers trying to optimize applications, or data operations folks trying to figure out what the right size infrastructure is to provide for a given application, or whether that's architects trying to understand how to migrate things to the cloud and which platform to use and how to structure all of that. All of those people, in order to govern and manage cloud costs, have to be able to work together. Each one of them plays a vital role in the chain, and what happens a lot today is that everyone's using disparate point tools, their own visibility into their own end of what's happening, and no one's on the same page. And everyone's pointing fingers at each other. Operations is saying the reason that we're having performance problems in this application is because it was bad code or a bad join. And data engineers are saying, no, you didn't allocate the proper provisioning of resources for my application. And so, that goes on. And FinOps folks are just trying to make sense of it all and trying again to listen to them, right? So it's challenging. This is a recent survey by the state of FinOps from the FinOps.org. And this shows the top challenges of FinOps organizations. Does everyone here have FinOps in your businesses? Who's responsible for cloud costs?
Used to be. Yeah.
Used to be? Who's responsible for cloud costs today for the data platform? You guys? Just someone in finance?
Yes.
Yeah.
Finance of the data warehousing team.
Okay. Well, whoever's responsible for it, whether they're called FinOps or not, these are the challenges that they face. And I think these are pretty universal challenges you'll probably recognize. The first thing is getting data engineers to take ownership of optimizing their applications. That's hard. A lot of them aren't experts in how to figure out how to optimize those applications. And a lot of the applications that were running on premises didn't really need to be optimized, right? Because if you used more compute power, it didn't really matter because it was limited by what you had in your data center. Another one is accurate forecasting of spend. This is a huge problem in cloud for data because it's very difficult to get visibility and understand what's going to happen. Enabling automation, reducing waste, and just aligning things and getting the organization to adopt some way of managing cloud costs in the first place. Next slide. So the good news is there actually is a better way to solve these problems. And there's a new class of software platforms coming out, like Unravel, that are designed specifically for data teams and the modern data stack. As I said before, what's been happening previously is folks using legacy tools that just weren't designed for this purpose. So we see a lot of customers who are using DevOps observability tools like Datadog and Dynatrace and things like that, which are amazingly wonderful tools, but they're designed for DevOps and web applications. And DataOps and DevOps are two wildly different sports and involve very different technologies underneath them and very different processes, managing data pipelines, data quality. These things are very different from DevOps. So what we typically see is sort of a hodgepodge of different tools being used by different players, and that's a big part of the problem. Data ops or data ops observability or data observability tools solve this problem. They provide one platform for all these things to happen together. And the way it works is really breaking this down, at least on the cost aspect, into these three phases. The first thing that you have to have in order to be able to manage costs is observability. You need to be able to see what's happening at the granular level in your organization on the data jobs and applications that are being run, who's running them, which ones cost the most, and be able to have complete visibility of that. The second is, once you have that visibility, you can then begin to optimize them. And we're going to talk about each one of these individually and what it takes and how to do it specifically. But to optimize the applications, you first have to be able to see them, and then there's multiple dimensions around how you can optimize them to perform and reduce costs in the cloud. And then with those two in place, you really then can use automation to drive governance and put guardrails in place so that you can be confident, one, of what your budget should be, and then you can actually proactively manage to it so that you can make sure that that spend doesn't overreach your budget before that happens, right? So next slide. So let's start with observability. You can't fix what you can't see, right? And the biggest problem, next slide, in dealing with the modern data stack in the cloud is that most companies don't have access to the right telemetry data, because those DevOps observability tools that we talked about before don't collect the telemetry that's needed from Spark jobs and from Kafka and all of the modern data stack technologies that you need to have that visibility. So you need to have visibility at the application level, the workload level, user, you need to understand all the data lineage, the data quality, how that's all flowing through your data pipelines. That's all part of the observability you have to have in order to manage the modern data stack. And that starts with having the right telemetry to begin with. With that telemetry, together with those metrics and logs and traces that you have for your infrastructure observability, you can correlate them together and then begin to get a really good understanding of what's happening in your modern data stack and throughout your entire data pipeline. Next slide. And with that, with a platform, a data operations platform like Unravel, you can begin to apply tags to all of your jobs and all of your users and begin to understand what's happening with your spend in business context. Who's spending money? Why are they spending money? How is that money delivering, those jobs actually delivering ROI for your organization? And what's the business impact? And you can report up on that and really have everyone understand what the value drivers are for your business. Then you can also set budgets, and you can track and manage the spend according to budgets proactively, and you can have alerts be sent out as the spend threshold approaches what those budgets are. Again, because the goal here is to manage spending up front rather than dealing with overspending after, right? And so having the visibility enables you to have an understanding at the departmental level, the user level, the application level, whatever makes sense for your business. And you also have visibility into kind of where the money is going on a much more granular basis. So it might be, for example, that a lot of money is going to running jobs that are not mission critical for your business. Well, that's important to know, because then you can start to manage that, right? And spend less money on those non-mission critical applications. Or it might be that some of the applications that are driving a lot of the spend are actually very inefficient applications. And so you know the right ones to fix that'll have the biggest impact on your spend. So just having that visibility at that level of what's driving your costs gives you the ability to then be able to manage it much better. And also understanding the trends in the usage patterns enables you to understand things like, what kind of instance do you need for a given application? What's the way to optimize that and the usage so that you can have the performance be as good as possible, but then also, spend the least amount for the applications that you are running. Welcome. And with all that in place, you can now have alerting so that, again, I think all of this, when you have the right telemetry and the right visibility, you can then begin to drive automation that enables you to much more effectively manage it across all of those roles of the data team, right? So everyone's on the same page, or on the same platform, everyone has the same visibility, and you can have alerts to say, what do you do about things? You can run chargeback reports, so or just, if not chargeback, showback. So that each area of spend can kind of have accountability of that spend on their own, because everyone can see it and understand it and manage it. And finally, and this is, I think, a really, really big problem for most of the customers that we have, is how to accurately forecast what the spend will be. And if you don't have that granular visibility and understanding of what these jobs are and why they're running and when they're running and all of that, you can't forecast. All you can do is guess, because all you have is visibility at the very top level of what's going to the top level cloud spend, but you don't have visibility at the actual job user level, application level, so you can't. So with a platform that's designed for the modern data stack, you can accurately forecast what those costs should be and be able to justify that going forward, and you talk about what the budget should be. So that was observability. The next phase is optimization, right? So once you have that visibility, now comes the fun part. Now you can begin to actually optimize all that infrastructure so that you can save money and spend money the way you want to spend money to drive real value. So it may not decrease your overall spend, but allows you to spend that money where it matters most and be able to measure that ROI and have really good business discussions with the folks at your company around why you're doing all this and why it matters. You were great earlier, by the way. I really enjoyed your talk.
Oh, you're so generous. Thank you.
Okay, so optimization. Optimization is really driven for modern data stacks with AI and machine learning. Why? Because they're super complex, these modern data stacks. And there's as all of you know, a huge shortage in talent and really being able to understand how to analyze and understand root causes and fix things in every company. Data jobs are the most in demand, the hardest to get. And so the expertise just isn't there at the level that everyone needs. So you need that machine learning to be able to provide those insights and let people know what they need to do and how they need to do it. Number one. The second thing is you need all those different people in the organization to have the same understanding of what needs to happen. We talked earlier about that finger pointing that happens, right? Because everyone's looking at things in their own silos. But if everyone's on the same platform and that platform's making it clear, here's what needs to happen to make it right, then people not only don't finger point anymore and they're not in silos anymore, but then they can self-service. They can just see it. A data engineer can just sees, okay, here's how I can make my application perform better. And I know if I look in the platform, if it's not performing well, I can tell why. Is it because of resource allocation? Is it because of code? What's the problem? Is it a bad join? What it might be. Everyone has visibility on that, and everyone can kind of self-manage and is empowered to drive that change. So that's the biggest key to optimization. And optimization involves a number of things, and this is why it goes across all the different roles in the data team, right? So the obvious one is data engineers and optimizing applications, the performance of the code, the joins, but then also in the data operations area, the allocation of the right resources. How do you know what's the right machine size to use, right? If you don't have visibility into the actual jobs that are running, all you know is what was allocated. How do you know what the right machine size is, and how much money could you save if you were using only the machine size that's needed? And what are the SLAs for that application? And how do you want to manage the instance type for that application? And when does it run? And what's the seasonality of that? And how do you want to think about that in terms of optimizing what the right infrastructure should be? So we kind of went through all of these. So when you have an application, a platform like Unravel that's designed specifically for the modern data stack and data teams, you have this visibility at all these levels and the machine learning that actually lets everyone know this is what it should be. So Unravel will recommend exactly what the right machine size should be. It'll give you insights into the data lineage and the data quality so that you can manage that and also understand the timing and actual usage, so you can use cold storage like Glacier, if that makes sense. All of these factors contribute into what your actual costs are, and optimizing your spend so that you're spending money where it matters to drive value, not uncontrolled and kind of hoping for the best. And that leads us to the last phase. With the other two in place, you now can begin to put in governance, right? So you can set guardrails based on what you want to have actually happen in your business, and then you can set the infrastructure to manage to those guardrails. So go back up one. And the key to doing that is automation, right? So we talked about having the visibility, we talked about having the machine learning and self-help for everyone to be able to make things better. But then the governance then requires automation triggers in place based on all of that, so that you can have proactive alerts and you can have proactive remediation when things go wrong based on the standards that you want to run your business. And that's really what these next slides say. So you can implement proactive guardrails so that you can prevent problems from happening before they happen, trigger proactive alerts to whomever it is who might want to be alerted, whether that's at the business level, the user level, whatever. And you can also automate remediation actions. Like, I don't know if any of you have experienced this, but with so many people in your organization running data jobs and not everyone being an expert, one bad join can have multiple petabytes of data running all weekend on a job, and all of a sudden there's a 6 or 7 figure bill that comes from that. So, an example of an automated remediation action is if a job takes significantly more time and compute power than what's expected, you can just automatically kill that job. It's just an example. So that's kind of it. In summary, we talked at the beginning of things be feeling kind of like the Wild West, in that there's this big rush for everyone to be able to get maximum benefit and value out of data. But all of us as data managers, data team managers, are kind of left with how do we control that? How do we bring order to that? Well, the way to do that is with a platform that's designed specifically for modern data stack and data teams, that allows you to do the observability and the governance and the optimization. Can I answer any questions for anyone?